Good morning. Today is April 9th, 2016. This is part 5 of this 437 part video series on grammatical systems, also known as generalized formal systems. And in parts 1 through 4, what we were talking about were first the applications of this theory. And then after we discuss some of them, we're going to talk about the definition. And then in the third segment, what we're going to talk about is open questions. So, in terms of applications, we had linguistics, computer science, theoretical physics, now the next application is music theory. And at some point during this series, one of these parts will be talking about each one of these applications. But I just wanted to kind of pique your interest in terms of what grammatical systems theory is possibly useful for. And in general, any symbolic system will be within the purview of grammatical systems. So I'm not going to define what a symbolic system is. So an example would be English, code, descriptions of reality in terms of theoretical physics. And in music theory, we would have sheet music. So these are some of the applications of grammatical systems. And there's one last thing I want to say about theoretical physics. With regard to theoretical physics, I mentioned the mathematical universe hypothesis. And I talked about we have seemingly two worlds, things with mathematical properties, things such as electron, photon, neutron, atoms, quark, things like that. These all have mathematical properties like mass. Photon has momentum. Electron has charge. Neutron has, well, no charge, but an atom has atomic weight. These are all numbers. Quark might have spin or something. All mathematical properties. Things with. So there's two worlds, okay? And so what I'm doing here is I'm explaining the mathematical universe hypothesis in non-technical terms. And in the seemingly other world, we have things. The MUH, or mathematical universe hypothesis, is that these two worlds are the same. And the way they state that is things only have mathematical properties. Now, that's actually very far from the technical statement of the mathematical universe hypothesis. This is just an intuitive feeling for what it's saying, and something that's closer to the true MUH would be something along the lines of reality is a mathematical structure. So not just the physical universe, but reality itself is a mathematical structure. And the other, so there are parallel universes of 4 varieties. Okay, each variety is kind of more encompassing than the one before it. The level 4 reality, or parallel, is some mathematical structure. And now Max Tegmark, who discovered this, Max Tegmark never specifies which mathematical structure reality might be. Okay? So, reality as a mathematical structure is the hypothesis that we want to confirm or deny. And where my research comes in is, the question is, which structure is reality? There's a website you can go on with hundreds of different types of mathematical structures. Hundreds. And the question is, are any of those reality? And I don't think so, because none of them are all encompassing. However, what we're going to do is next, what we're going to do is define grammatical systems. And then I conjecture. The conjecture is that the structure that Tegmark is looking for is nothing other than the totality of all grammatical systems. Okay. So grammatical systems have some applications to things outside of math. Oh, another application, well, because mathematics is a symbolic system, mathematics is one application of studying grammatical systems. And so this is useful. Grammatical systems theory, useful in set theory. One of my theorems here is we give a way to prove something about all sets. And the corollary of that is the well-ordering principle. The well-ordering principle is a statement about all sets, and it says that all sets can be well-ordered, and that's a very peculiar theorem, I think. It's shocking, actually. Okay, so the other thing that should be noted here with parallel universes is that with parallel universes, let me describe what types of things are different. Okay, so in the first type of parallel, well, what we have is a history class in school, physics class, and math class. Now, in the level 1 types of parallel, so these are types of parallels. In the first type, history class may be different. And physics and math class are the same as ours. Same as ours. And then math class is also the same as ours. In the second type of parallel, history class is maybe different. Physics class has different values for the 32 important numerical constants. So the mass of an electron might be different, but the equations are the same. Okay, and life may or may not exist in different parallels, or at least life as we know it. Math class is same as ours. In the level 3 type of parallel, history class may be different. Physics class is going to have different equations and constants. And math class is same as ours. And in the level 4 type, this is maybe different. History classes may be different. In fact, it's probably different. Physics class is maybe different. And math class is different. I'll put in quotes. So the defining trait of the level 4 type of parallel is that even math class is different. And grammatical systems theory addresses the question of how might they be different. So grammatical systems theory addresses the following question: how might the math classes be different in different parallel universes? Okay, so that's going to be the end of part 5 of the video series. Okay, so just to review, I still have not defined grammatical systems. I'm starting off with what are the applications of this theory: linguistics, computer science, theoretical physics, music theory, any symbolic system, meaning anything that can be written in symbols, and that includes mathematics. So grammatical systems theory would be a theory that shows some common threads between all of these subjects. And in part 6, we're going to actually define formal system and then generalized formal system. And then in part 3, well, maybe in part 6, we're going to do definitions of key concepts. Parts 7 and 8, we're going to talk about what are the open questions that I'm trying to solve and what have I done so far. So Also, to summarize, talking about theoretical physics, there is a mathematical universe hypothesis, which can be found on Wikipedia for more details. This was discovered or concocted by Max Tegmark. In non-technical terms, there's two types of things, it seems. Things with mathematical properties, and then things. And the mathematical universe hypothesis is that these two worlds are the same, so that things only have mathematical properties. That's actually not even close to the true statement of the mathematical universe hypothesis. A closer statement is reality is a mathematical structure. So this is really the mathematical universe hypothesis. It's that reality is a mathematical structure. Then I briefly talked about parallel universes being of four varieties. The level 4 parallel is some type of mathematical structure. The question is, which structure is reality? And I conjecture that it's the totality of all grammatical systems. And furthermore, in regards to theoretical physics, Max Tegmark postulates that there are four types of parallels. In the first type, physics and math class are the same as ours, but history class might be different. For example, the Germans may have won the war in World War II. In the second type of parallel, so these are just types of parallels. There might be one parallel where Hitler won. There might be one parallel where Hitler never existed. There might be another parallel where everybody was Hitler. Who knows? And then the second type of parallels. So each type of parallel has many examples. And then in type 2, history classes may be different. Physics class is also a little different. The constants that we rely on, there's about 30 of them, like the mass of an electron. Those are all slightly different, but the basic equations of physics are the same. And then math class in type 2 parallels is the same as ours. In type 3 parallels, history is the same. Physics is very different. We not only have different constants, but different equations entirely. So for example, Maxwell's equations for electromagnetism and E equals mc squared is going to be different. It might be E equals mc to the 2.07. And math class in type 3 parallels is the same as ours. And then finally in type 4, history class is different, physics class is different, and math class is different. But I put it in quotes because it's not really different. In fact, it's all contained within grammatical systems theory. So the part 6 of this video series will focus on the question, how might math class be different in different parallels?